Welcome back. Today is the first day of the last unit before the end of the term, also the end of the semester. We are going to be having a test in roughly a week and a half-ish, and then we will be preparing for exams. But the unit that we are going to focus on is atomic energy, and as a result of that, we're going to first talk about fusion. So a couple of things that we definitely need to review or go back over when it comes to talking about, in order for us to talk about atomic energy is, oh boy, what are the three subatomic particles? So you should remember them as protons, neutrons, and electrons. And you also should think about where they're located, or remember where they're located. The protons and the neutrons are located, they're located in the nucleus. And the electrons are located in the space around the nucleus, or outside of the nucleus. Another thing that we need to remember or keep in mind is the atomic notation as you're given it. So the number 7 on the top is known as the mass number. And the mass number is equal to the number of protons plus the number of neutrons in the nucleus of the atom. And so in this case, the mass number is 7, and the atomic number is equal to the number of protons in the nucleus of the atom. And so in this case, number 3, the 3 is the atomic number, and the Li is the element symbol. Which is important, and we're going to talk about that a little bit more detail, or we're going to use this notation rather in a little bit more detail at the end of today's class. So, first of all, fusion. Fusion is defined as, or it basically is when two atoms combine to form a new atom. And by new atom, I actually mean a new element. And so then the other thing that we need to consider is that the protons and the neutrons, oh boy, in each nucleus combine into the nucleus of the new atom that's formed. And so that's a definition of what fusion is. Now, there is a picture that we're going to talk about here just a little bit in terms of what fusion actually is. So in the first column here, we have nuclear fusion occurs when two atoms combine to form a new atom, and they usually also happen to produce a neutron. Sometimes they do, or most of the times they do, but sometimes they don't. So here we have deuterium up on the top, which is a hydrogen atom with a neutron, and we have tritium on the bottom, which is also an isotope of a hydrogen atom with two neutrons. When they combine under intense extreme temperatures, where they can overcome the repulsive forces of the two atoms, and as a result of that, they can combine. And when they combine, what ends up happening is that one of the neutrons gets released, which is this guy right here, and the remaining neutrons and protons stick together and they form a new atom, which in this case we're going to say is helium. The other thing that happens is an incredible amount of energy is produced, and we'll talk about that energy a little bit later, but for the time being, fusion is when you take two atoms, you mash them together, and when you mash them together, you generally are going to produce a brand new atom. Now, the idea for what is fusion, fusion occurs in stars. And as a result of that, this is how elements are created. We'll talk about that in a little bit more detail in a second. So the other thing that we need to consider is that the first matter in the universe was made up of all hydrogen and some helium. And the process of fusion created all of the elements that occur naturally. So there are some elements that are man-made, and those were not created in stars. But the rest of the elements that are naturally occurring elements were created through this process called fusion. This right here is a video clip that explains how fusion works in a little bit more detail. I would like you to pause this video, go back to Google Classroom, and click on the link that is attached to this post. Watch the video, it's roughly 6 minutes, and then come back and finish the notes. Okay, so now that you've watched that, you have a little bit better understanding about how stars make elements. We're going to briefly talk about it here. So this is a picture of a star. It happens to, I guess, look like our sun, but it's a picture of a star, and there's a lot of things going on here. So the temperature of the star increases as you get closer to the center. So the core of the star is warmer than the outside or cornea of the star. Heavier elements with more protons in their nuclei will require higher temperature to form, and therefore are only created at the center of stars. So essentially, when you're looking at this particular picture, you see that hydrogen is being formed, what appears to be on like the second or third level of right here of the star. Then from there we have helium being formed, and then carbon being formed, and then oxygen being formed, and so on and so forth, all the way until the center of the atom. And the video clip did a little bit more explanation as to what happens with the other atoms, the other more heavy atoms that aren't like iron ash, for example. And that you don't need to know. You just need to know that fusion creates new elements, and those elements are created inside of stars. Now, fusion on Earth. Just so that we are clear, because of the amount of energy and temperature required to fuse two different atoms together, it is nearly impossible to create fusion on Earth. Due to the extremely high temperatures needed. Something like you might need something like 150 million degrees Celsius or something stupidly ridiculous like that. However, if we could find a way to safely perform fusion on Earth, it could be a huge source of renewable energy. And that's critical and key. At this particular point in time, we are unable to harness that energy, and as a result of that, scientists are trying to figure out a way to make that a safe situation on Earth. If they could, it would be great. Chances are we're not going to see it in our lifetime, though. Now, there are a couple of types of fusion things that you need to keep track of in terms of like your homework tonight. So, first of all, we have to keep track of or remember when two atoms fuse together, the new atom's number of protons and neutrons is equal to the total protons and neutrons from each original atom. So, for example, a hydrogen atom with one proton and one neutron fuses with a lithium atom with 3 protons and 4 neutrons. The new atom has, well, if the number of protons and neutrons from both of the atoms are equal to the total number of protons and neutrons in the new atom, then that would tell me that I would have, let's see, 1 plus 3, so that would give me 4 protons and 1 plus 4 would give me 5 neutrons. So in that particular example, we were told the number of protons and neutrons, and we just had to kind of figure out how many protons and neutrons were present. Now, in this particular example is also like what you're going to see for homework tonight. So a couple of things to remember is that mass numbers and atomic numbers should be equal. What word is that? Should be equal on both sides of the arrow. Okay, so taking a look at what we've got going on here, I see that the mass number for carbon is 13. The mass number for fluorine is 18. And so when I go ahead and take 13 plus 18, because those mass numbers have to be the same, I'm going to get 13 plus 18. Let's see, 13, 18, that's 11, that's 31. So I get 31. Okay. Then my atomic number for carbon is 6. My atomic number for fluorine is 9, so I'm going to take 6 plus 9, which is 15, and put that down here. Now, so this is my new mass number. My new and improved mass number. And this is my new atomic number. And if I go look on the periodic table for an element with an atomic number of 15, I can see that that happens to be the element phosphorus. So that tells me that if I take carbon 13 and fluorine 18 and I fuse them together, I get phosphorus 31. Now, that's a great example, but I'm going to go ahead and, oh boy, and show you one more example that might be like one that you see in your homework tonight. So what I'm going to do is I'm going to go back and I'm going to take a look at, let's say, something like this. So I'm going to say that we had 23 and 11. And I'm going to tell you that that's element sodium. And I'm going to have an arrow way over here and tell you that I have 55 and 26. And I'm going to tell you that the element that's formed there is iron. So what I need to do is I need to go back and figure out a mass number and an atomic number for the element that's missing. So what I'm going to do is I'm going to subtract the mass numbers. So I'm going to take 55 minus 23. And when I get 55 minus 23, let's see, that's 2, that's 32. So I get a 32 up here. Then I'm going to take my atomic numbers and subtract those. So that's 26 minus 11. So that's 5, and that's 1. So that gives me 15. So now I'm going to go and look for the element on the periodic table that has the atomic number of 15 and I'm going to go back and look again, and in this case that happens to be phosphorus. So I found that the missing element, or the element that would have combined with sodium to produce iron 55, would be phosphorus 32. And that's basically what you're going to have to do for homework this evening, which happens to be worksheet number 1, which is based on fusion. And once you have completed that worksheet, which happens to be a two-sider, you will be done for the evening, and you should have some time in class to work on that. Thank you for paying attention, and good luck on your homework tonight, and we will talk about it tomorrow.